This video presents a demo of our service architecture and framework as developed in the Mobile Cloud Networking project. First, what is MCN? Its goal is to exploit cloud computing as infrastructure for future mobile network deployment and operation. At the core, MCN is about the movement from systems that are self-hosted, self-managed, and self-maintained to cloud-native based software design that respects existing standards and management and operation of those designs instantiated as services or indeed network function services. To achieve such a goal, a specific service-oriented architecture drawing on existing industry standards has been developed to deliver end-to-end composed mobile telecom and cloud computing services. The result of this development is what we demonstrate in this video. We start first by describing how a MCN composite service can be developed, then follow up with a demo of the full deployment and provisioning of that service. Developing a new service for the MCN framework requires a service developer to create a specific bundle called a service orchestrator, referred as SO later. A SO contains both an infrastructure template graph and an imperative logic, as well as a graph of dependencies to other services as a service manifest. The template graph describes the different virtual resources composing a service: virtual machines, virtual networks, attached storage. This is typically in the form of an OpenStack heat template. The logic is the code which will be called at different steps of a lifecycle of a service, essentially from deployment to provision to runtime and finally disposal. It can be written in any language so long as it is able to answer the OCCI requests for the different steps of the service lifecycle. These two pieces are combined in a SO bundle. The next step of the vendor is to write a service description for the new service's service manager, referred as SM later, which will be the contact point for the end user who requires a new instance of a service. A service manager answers OCCI requests to create, retrieve, update, or delete an instance of the service. It contains the previously described SO bundle as well as a custom list of attributes specific to the service, set by the service manager developer. The service is now ready for deployment by the orchestration framework. The next two slides show the flow of requests between each component. These steps are repeated for each new service creation request. First, the end user requests a new instance of the service to the service manager. This triggers a request. At step 3, the cloud controller to deploy a new OpenShift container, which is deployed with a Python cartridge and configured at boot time to install the MCN Cloud Controller SDK at step 4. Once the container is ready, the service manager uploads the SO bundle at step 5. The container automatically deploys the SO as a web application, which can then be called by the SM, still using OCCI. The SM issues a deploy request to the deployed SO at step 6, which then deploys its infrastructure graph through the cloud controller at step 7, which in turn deploys the heat template on the underlying OpenStack infrastructure at step 8. The SO is also able to provide instance-specific configuration to its newly deployed resources, still using the cloud controller through its SDK. Disposal requests follow a similar flow. This demo shows the deployment of the digital signage service, one of the composed services within MCN. In short, it is used to distribute content to distant registered video players across a large area. As a complex service, it uses its own resources described in its SO's template graph, but it also has external dependencies to other services: content distribution, rating charging billing, monitoring, and DNS represented in the service manifest. This version of the orchestrator uses a specific service, the end-to-end service, to coordinate the deployment and provisioning of all the other subservices. As a normal service, the end-to-end has a SM and a SO. All the other services, SM and SO, are also represented on the diagram. Let's start with the initial deployment request. The next screen shows the logs of the different services managers involved in the deployment process. You can see the request sent as a POST request using the OCCI syntax. The request is for a service of category E2E using a token as credentials for the specified tenant name. The next step is for the end-to-end SM to create an end-to-end SO. On the top left, the end-to-end SM logs show that the post has been received and that a request has been sent through the cloud controller to generate a new container. The container will deploy the SO bundle of the end-to-end service configured to retrieve the endpoints of the service it depends upon and deploy an instance of each of them. At step 3, the deployed end-to-end SO retrieves the endpoints of the service managers of the services it requires through the corresponding CC SDK call. It then sends a service deployment request to each of them simultaneously. In turn, at step 4, these SM each create an instance of their SO as seen previously. Going back to the logs, you can see that each service manager is now sending a request to the cloud controller to instantiate a new SO instance with their own SO bundle. Contrary to the E2E service, which is tasked to control other services and does not deploy its own resources, the other services typically use the cloud controller to deploy their own heat template. This request is illustrated at step 5. Step 6 represents the actual deployment of resources. The logs are now showing the deployment and provisioning requests sent by the service managers to the new SO instance. The SM periodically polls the SO instance for its status. This is useful to start the provisioning phase once the deployment phase is complete. Once the service is ready, a status request shows "Create Complete" as its current state. At step 7, each SM knows that its SO is in the provisioned state. At the next step, the end-to-end SO then retrieves all attributes from all the deployed services, such as the endpoints and access credentials. Before going further, this is a screenshot of OpenShift at this time of deployment, showing 6 running instances, one for each deployed service orchestrator. The first 4 heat stacks on this screenshot are the 4 newly deployed heat stacks, one for each service besides CDN, which does not use its own stack but rather account creation on another infrastructure. If we click on the one corresponding to the DSS instance, we can see its topology and the resources deployed. Finally, we see in the details of the stack one of the attributes of the deployed service in the output part. Now going back to the deployment process, step 9 is the provisioning of the E2E service. Its SO receives all the attributes from all deployed services and issues provisioning actions to each of them using attributes from the other services as input. For instance, DSS requires the CDN endpoint URL, but also the monitoring credentials, among others, to be completely ready. This is also the case of DNS, which requires monitoring to be able to properly log requests to a common front end. Step 10 and 11 represent the propagation of these update requests down the stack till the actual heat templates. This exploits latest features of heat templates, allowing reconfiguration of resources without any reboot of the actual virtual machines. Going back to the logs, we will now focus on the final configuration of the DSS service at the bottom left screen. You see first that the service is in create complete state, but at this step, it is still lacking information on the other services. The update has just happened. The first two OCCI attributes shown come from the CDN service, the management endpoint as well as the origin endpoint. The state is again set to create complete as the final configuration has been updated. At this step, a GET request for status on the DSS service would show all the attributes generated by DSS as well as the ones it uses from external services. This is illustrated by step 12 in the diagram, with step 13 showing that the end-to-end SO also retrieves the updated attributes values from all services. Finally, the periodic status poll from the end-to-end SM to its SO shows a create complete state of the instance, indicating that the final composition was successfully run. The Service Manager logs now show a GET request from the actual end user to the end-to-end SM. It shows what we have just described. The service is now ready and information on all the necessary endpoints to exploit it is now ready. The request is the final step 15 in the diagram.